Okay. So next up is head and tail. These work very similar to um, the commands in Bash. The one difference is that by default, if you don't put any argument, you get 5 rows with head and tail. With Bash, you get 10, but you can control that by putting a number here, like we do here. So this is giving us the first 5 rows, and this is giving us the last 5 rows. Now, the Jupyter Notebook, or even the IPython environment, if you type the name of a data frame without head or tail, and it's a large data frame, you won't see the whole data frame printed to your screen. It won't, fill up your screen with data. It will truncate the middle and just show you the top and the bottom, and then you can click, and often you can expand that to see the whole data frame. So I can show you this here. Okay, yeah, you can see that. Where'd that go? So clicking on this left bar expands and contracts that window. Within the window, you can scroll up and down, but you can still see that it's only showing us the first 30 rows and the last 30 rows. You can change that setting. It's a Pandas notebook view kind of setting that sets the max number of rows. But typically, you can, if you need to know what's in a certain row, you can index that particular row. So speaking of indexing, there's several ways of doing indexing in Pandas, and they have advantages and disadvantages. So we have this bracket notation and dot notation, which work on the labels of columns. We have the dot loc, which works on the labels of indexes, and actually it also can work on column labels. I should change that. And then we have the iloc, which uses the positions of indexes and columns. So Pandas supports both label-based, which is using either of these top 2 forms, or positional-based, which uses this last one here. So depending on how you want to do it, you have the option to do it either way. So if we just look at this data frame, hopefully I didn't change it too much so this still works. So we have this data frame here. If we want to pull out just one column, the easiest way is to do this bracket notation. Is one easy way to do it. So this will give us that one column, the column team, using the column header, and this generates a series, because a series is one column of a data frame. And this series has data type object, and the name is team. That's the label of the column, and that's straightforward. If we want multiple columns, we can pass a list of labels, a list of column headers. So we're going to get team and random, and they'll be in the order that we specify as well. So this is the way we can change the order if we want. Now there's another related type of column indexing using dot notation. So this is a kind of a shorthand for the above here. If the column header is only alphanumerics, it doesn't have any spaces or anything. It can have underscores as well. So this is why we like to use underscores in our column names. I'll add this here. And remember, I always update the GitHub with the latest version of the notebook, so you don't have to worry about noting all these changes I'm making. We can use this dot notation, and so this gives us the same output, but in a simpler way, just with the dot. Another way we can do this is using the loc style. So if we just want to get a row by name, we can use .loc and the name of the row. So this is like, you can think of this as identical to this notation, except we just have to add .loc before the brackets. And I sometimes, like before, sometimes I got confused. I put a parentheses, but this doesn't actually require parentheses. It's just you put the bracket straight after the .loc. And if you want multiple rows, it works the same way. You can pass a list of those row labels using this loc method, using this loc style indexing, and get multiple rows. Now, if you want to do positional-based indexing, you use the iloc function. So by default, iloc will work with the row labels, or with the row numbers. So in this case, we have row 0 is what we're pulling out here. And again, we can use get row 0 and row 3 using a list of those positions, or pass a slice. So in this case, we're starting with row position 2, which would be the third row, C, and to the end. And we can also get columns using iloc. So this is a positional way to do positional indexing of columns. So in this case, we're going to use this notation that we've seen before, where we have the rows and then the columns. So in this case, we're going to use a colon to represent all rows, and then a comma, and then the column position. So we want column position 0 and 2. And in this case, I renamed it to Fibonacci, so we're going to get that last column, that column position 2 Fibonacci, and the column position 0 team. So there's a lot of flexibility. There actually used to be another one called IX, but that was deprecated because it was redundant with some of these functions. And so there's a lot of ways to index and slice pandas data frames. And one thing, let me see here. One thing I want to show is see if this works. No, I'll come back to that later. There are some cases where you want to, let me see. Let me see if I can get this to work. Okay. I'm forgetting what it is, but there's a way to do slicing between two positions, and with label-based slicing, you get both the front and the end slice, and not it works a little differently than position-based, but I have to look up exactly a good example for that. So one other thing here, we talked about this earlier, but you can transpose a data frame, so you can either use this dot transpose method, or you can use just a dot capital T. This is similar to MATLAB. And if we wanted to, no, it does not have the in place equals true. So if you wanted to make this permanent, you can do df equals df dot transpose to transpose that. Are there any questions so far? Okay, so one of the really nice things about Pandas is it makes it really easy to import and export different file types. It supports a lot of different file types, but the ones that I think we tend to use the most are comma-separated values, tab-separated values, which are both plain text formats, and then Excel. So it supports both XLS, which is the old Excel format, and XLSX, which is the new XML-based format. By default, if we have a data frame, we have this toCSV that works the same as, just like we can do from CSV, we can do toCSV. So we can write toCSV, and we just created a file called teams.csv. So if we go if we go one tab over to our home tab here, we can open up a terminal just right inside the browser, and so we can have a look. And we have this file teams.csv that we just created. So we can do cat and we can see this file that we just created. So this has the index label in the first column, and then team, random, then Fibonacci. So if we wanted to do a tab separated instead of comma separated, we can do toCSV. So we're still using the same function. So it's a little, you just have to know that CSV in here is a generic term for any kind of separated values. By default, it uses a comma, but if you want to use a tab, then you can say sep equals \t, and it will use a tab instead of a comma. This is the same syntax we use for read CSV, by the way. So if we want to convert that to a TSV, we use toCSV with sep equals \t. We can go now look in the terminal, and we see we just created a second file, teams.tsv. So if we cat, we can see now we have a tab separated. A little bit easier to read with the eye, but it's the same data. Whatever you prefer or whatever your code likes, you can use. In fact, there's a third option, or not a different option, but let's do this. Let's do CSV, but with index label. So we're going to do index label equals, we can just say index. So this, if we execute this command, now we go back and look at that CSV file. Now we don't have this empty cell here. We have, now it's labeled with an index. So that's, if you want to call that first column. So for example, in biology we do a lot with species tables, and often we have like that first column is the sample name. If you want that one to be called sample name, you can specify that. So that's a handy little trick. When you write that file, you can label that index column, because by default it doesn't have a label. Okay, then the last one here is toExcel. So you can just use this toExcel instead of toCSV, and you might get an error that says no module named OpenPyExcel. So that's okay. We can import that. So we can go back to this terminal, and first of all we can say conda end list to see which environment we're in and make sure we're in Python 3. So you should see Python 3 with a star next to it. So that means you're in your Python 3 environment. So now we're going to do conda install OpenPyXL. So OpenPyXL. Let's double check that. Yep. Hit enter. And this is going to be one of those packages that it shouldn't require us to import. It should just work in the background. Okay? When it asks you, you can say yes. All right, so that's done. So we can go back now and try this again. And it worked. So now, if you can see we have teams.xlsx. Now I can try the, let's see if my aliases show up here. No. Let's see if this works. Yeah. So on a Mac, there's an open command which will try to open the file using whichever program it thinks is right. So if you're using a Mac, that should work. Otherwise, you might need to navigate to that folder on your Finder. And you can see it's pretty cool. It created an Excel file from that same data. And in fact, I believe we also can do index label index. So, open that again. Yeah, so it supports that index label too. So it's pretty handy. It's going to add this formatting by default. I think that's just kind of the way it works, but it's pretty nice to have that option. Although be aware that Excel, when you open a file in Excel, it will try to figure out what kind of columns things are, and it can change the data. So unless you need to use Excel, I would recommend saving your files as text files, because then they won't be changed, and yeah, you have to kind of get experience with that. So just for completeness, we can read a CSV file using read CSV. We can also specify the index column when we create it. So we can say index column equals 0 and specify exactly what we want that index column to be. And again, we have this data types, dtypes attribute that we can run. Okay, here we go. So this is what we were talking about earlier. We have the ability to specify the data type of the columns when we import. So this is probably the most streamlined way to import your data, is to do it all, specifying if you want to have control over the data types, to do it when you read the CSV file. And as I said, there is a way to read a tab separated values file using read CSV. You just have to say sep equals \t. Here we're going to say index column equals 0, so we can have the indexes already as we were in that TSV file that we saved. Okay, and if we want to read an Excel file, we need to import this other package, XLRD, Excel read. So we're going to go back here and do conda install XLRD. Okay, say yes. I like to do this terminal thing in the Jupyter window. You can always make a terminal. It's doing the same thing it would do on your regular terminal, but there you need to, because your IPython is already running in the window, you need to open up another window and activate the conda environment to make sure that that package gets installed in the right environment. And the nice thing about this is that you're already in the browser, and it's going to open up a terminal in the environment that you're in. So, in fact, it tells you here, here's the environment location where it's going to install that. So we go back. We can now read an Excel file in addition to writing an Excel file. So that's really handy. Finally, this should be the last thing. Yep. There's a ToDateTime function. We touched on this a little bit, and we're going to have an entire lesson about time series data. But if we look at this file, we see that if we look at the D types, this date column is an object type, or it's just stored as strings. So the pandas and the notebook doesn't have any idea that that's a date column that has special information that it represents dates and times. So we can convert that. One way we can do that here is to use this pandas function ToDateTime to take that column and create a new series called time, which we'll then look at here. So we can see now that this series has it has itself an index, but the values now are of the data type date time. So we can then save that series as the date, replace the data that's in date with this new improved date time thing. And so we now can see that we've converted these to this, and if we look at the data types, we can see that that column has been changed. Now, there's another way we can do this. So again, we're going to import this file again. We can say the key part here is that we're going to have parse dates equal to this list containing all the columns where we want to parse the dates. So we then look at that, we can see that this is a way to automatically parse the dates. So one could use this dictionary style import to specify the data types of all the other data columns, and then specify the date, any kind of new date columns using the parse dates attribute, and then take care of all the data typing of that data frame immediately when you import. Ideally that you would do that, but oftentimes you import the data frame and you have a look at it, and then you maybe want to make changes afterwards. So it's a matter of preference. But there's a lot of options for that. And as we saw kind of briefly in that matplotlib, very quick example we did last week, that if your date is now converted to a DateTime object, there's all kinds of additional functionality, including how it's plotted. The program will know that those aren't just. It so happens that these are equally spaced 6 minutes apart, but they wouldn't necessarily have to be, right? So having that ability to know that they're dates allows various things to work better in how they're plotted and handled. So that is sort of the first, some of the first functionality of pandas. If we go back to our schedule, we're going to do a lot more pandas on Wednesday with a number of new functions. And then next week we'll get into plotting, which is all going to be on Wednesday. So these two lessons, 13 and 14, will both be on Wednesday morning. Then the following week we'll come back and do time series and what I'm calling group operations. And then we've got some statistics, visualization, some more advanced Python, and then GitHub. And that's the rest of the quarter. So you'll get some practice with pandas in the assignment for this week, and I will get these assignments graded here for you guys as soon as possible. So that's all we have for today, and if you have questions, please let me know after class.